Okay, so welcome back to the fifth week of TA live sessions for Artificial Intelligence KRR. Um, so, is my audio clear and is my screen visible? Can someone just confirm it quickly?
Yes, sir.
Okay, thanks for confirming. So, yeah, um, today we'll be discussing some of the questions from week 5 of the course. We were supposed to have this last week, but I was traveling, so we couldn't have it. But we're having a compensation class today, and we'll be having the regular class tomorrow, which is Tuesday, 6 to 8 p.m. Okay, and tomorrow we'll be discussing week 6 questions, I think. Today, let's stick to week 5 questions. Okay, so yeah, without any further delay, let's continue. So the first question is select the correct options. Okay, and you have to select which of the following is correct with respect to backward chaining and forward chaining. Basically, we have to decide whether backward chaining and forward chaining are sound or complete, or both. Okay, so what do you think would be the correct uh, choices in this question? So this is kind of a recall based question. Okay, this is if you have gone through the lecture slides, you might be aware of whether each of these methods is sound or complete. So try to recollect it from the lecture slides. Okay, any guesses? Okay, so maybe I'll go ahead and show the answer, and you can verify it yourself whenever you revisit the lecture slides. So the correct answer in this case would be that both backward chaining and forward chaining are sound. That is, they always produce and only produce sentences that are facts that are supposed to be true, but they cannot generate all the facts that could be true, and hence they are not complete. Okay, so both of them are sound, but they are not complete. So this is the answer. The correct options are A and C. I hope this is straightforward. Let's move on to the next question. So this question tells us select the formulas that are in CNF or conjunctive normal form. Okay, so yeah, I'll let you think over the options for a while, and then we can discuss the solutions. So which of these options do you think would be in CNF? And yeah, I'll give you a couple of minutes to think over it.
B, D, E.
Okay, thanks for your answer. So there's one vote for options B, D, and E. What do the others think? So just as a refresher, let me go over what the CNF actually is. So basically, a formula in conjunctive normal form has the following structure. Okay, it has C1 and C2 and up to Cn. So there are n entities that are connected by these and operators, and each of these Ci in turn is a combination of different entities D's, di1, di2 that are connected by OR. Okay, now each di in turn is either a L literal or negation of L. Okay, so this is basically what CNF means. Now with this definition in mind, let's go back to the question and let's go through the options one by one. So the first option is A or B or C. If we think of A or B or C as a single D, okay, so here definition said that each Ci could be di1 or di2 or something. Okay, right? So let's remove I for now. Okay, let's think that C equals d1 or d2 or d3. So doesn't this A or B or C fit the definition?
Yes, sir. I think it fits the definition.
Yeah, that's correct. So because of that, this is in the conjunctive normal form. The only subtlety being that this formula contains only one such C, right? So this F equals to C1, these things are not there, right? So even that is following a conjunctive normal form. There can be a formula that does not contain any and, just contains one of these C's, which is a clause basically. If the clause follows this particular setting or this particular framing, it is still in the conjunctive normal form, right? But then we have to make sure that this is the only clause in the formula and there are no other operators present other than or appropriate at the appropriate places. Okay, so A is correct. What about B? Is this in conjunctive normal form?
From my understanding, I think it's no.
It's not. Okay, think a bit more. So here we have three entities A, B, and C that are connected by AND operators. Now look at each of these individual entities. Can we say that A itself is a clause?
Yes, it is possible.
Yes, sir. It's possible.
Yeah, that's right. It is possible, and the reason being that so each of these D's, right? This could be either a literal or a negation of the literal, right? So here we have A, right? Not a negation of A or B or C. So each of these clauses will be equivalent to just A, B, and C individually. So F will be A, C1 which is A, and C2 which is B, and C3 which is C, right? So this is also in CNF. So B is also in CNF. I hope that makes sense. Let's go to option C now. What do you think about option C? Is it in CNF?
It is not in CNF because your implication is there.
That's right. It's not in CNF because there is an implied operator or implies operator in the formula. Now, one nuance here is that C can be converted to a particular form where it is in CNF, but this question doesn't ask us to do that. So be careful when you're asked about when you're just asked to identify whether something is in CNF or not. Okay, here we are just asked to identify whether the formula are in CNF or not. With that question, C is not in conjunctive normal form, but it can be converted into CNF. That will be a different question. Okay, for this question, C is the wrong answer. Now, what about options D and E?
D and E are correct. Are in CNF.
Are you sure? See,
I think in D, if we start simplifying, then we
no,
should
no.
think of.
We shouldn't be simplifying here. The question only asks us whether the given formula in the form that it is
No,
given,
no, no.
whether it is in CNF or not. Okay,
Said,
so
said they will not be in CNF.
that's right. So whenever we have a negation, it should be in front of a literal, not in front of a clause. Okay,
Yes, sir.
it could be in front of A, B, C, or D. It shouldn't be in front of a clause, right? But here what we have is, here we have a negation in front of a clause A or B or C. That's why D is not in CNF. Again, like one of you was pointing out, if we simplify this further, this may end up being in CNF. Okay, but that is not what this question asks us to do. So D is not correct and E is actually correct, because each of these, not A or B or C, this is clause 1, not C or not D or E, this is clause 2, and both these are connected by an AND operator. So E is also in CNF. So the correct options are A, B, and E. Okay.
Sir, one query is like as you are explaining us, like for example, I mean, right now you are explaining about CNF.
Yes.
So it may be any other topic. So like as this, I just don't want to name the topic. So if there is a question like whether identify whether the following formula is in Horn clause or not, or whether this can be solved with back chaining or not. So if they are asking something, whatever the form that is given, we have to directly see it, right? Not the simplified form.
Yes, generally yes, but then I would ask, read the question very carefully. Sometimes, most of the time, the questions will be very straightforward. So you just have to
Simply, sir, like
understand.
this. You can assume the following question format. Like, for example, if there is a question, something like this. Select the formula that is in CNF.
I
So we
understand
need
your
not
question,
think
Shyam.
of
Please,
simplifying, right?
can I complete?
Yes, sir.
Yes. So, like I was saying, that carefully read the question. If the question is in a form like this, given over here, select the formulas that are in CNF. You just have to assume whatever is given. Sorry, you have
Okay.
to consider that as a candidate, and then see whether that can be set to fall in the formula, the setting of a CNF or not. But
Okay.
it's not possible to always generalize and say that whenever you are given an X type of question, do answer it in Y type of way, right? That is a generalization that is not possible. There will be some questions that have some nuances, so that's why I'm saying that read the questions very carefully and then answer them. Most of the times
Yes,
questions
sir.
will be
Because
straightforward,
last
but
week assignment,
can I
that
complete,
was
Sham?
a bit confusing. Yes, sir.
Yeah, so what I was saying is that most of the time questions will be straightforward, but like I
Yes.
said, there will be nuances in some questions. So just read your questions very carefully. Also examine your solutions and see if the solutions. Yeah, basically just read the question carefully. That's all I'm going to say. Yeah, please
Okay.
continue, Sham.
Okay. Okay, sir. Okay. That's it, sir. You can go ahead.
Okay, thank you. Okay, so I guess let's move on to question 3 then. Okay, so the question 3 says that select the formulas that are in clause form. Okay, so again, like one of your friends, Shyam, was asking in the previous question, here you have to assume whatever is given to you in the option is what you have to deal with, and for each option, you have to decide whether it is in clause form or not. You shouldn't think about simplifying it any further, just think whether the given option is in clause form or not, and then say yes or no. Okay, so yeah, I'll let you think for a while and then we can discuss the solution.
Sir, class form means I think it is another name for CNF, right?
So let me go over what clause form is.
Yes.
I don't think it's exactly equivalent to CNF, but let's go over it. Let me search for it. Yeah, so this is the clause form in first order logic. Okay, and it says that a first order formula is in clause form if it is of the following form. So there should be this for all or universal operators for each of these variables x1, x2, up to xv, and then they should be preceding this set of um, clauses c1 and c2 connected by these conjunction or and operators, where each ci is a clause made of disjunction of literals. Okay, so it's similar to CNF, but just with the added criteria that there have to be these universal quantifiers. Okay, the clause form contains only universal quantifiers, so existential quantifiers shouldn't be there. Okay, so yeah, so this is basically what clause form is. It's just an additional nuance added to the conjunctive normal form. And with that definition in mind, which of these options do you think would be falling in the clause form? Okay, so yeah, we have
Sir, I think C could be in class form.
okay, so we have two votes for option C in the chat as well as in the in the live audio, and so options A and B are clearly not in clause form because each of those has an existential quantifier.
Existential quantifier. Yes.
Right. So we can just go over, like you can straight away reject A and B. C is actually in clause form. What about option D? Isn't D just a restatement of option C? Just look carefully.
Yes, sir. I think it's a columnized form of C,
No,
I
it's not
guess.
scolumized. Scolumized would have a scolum where this either scolum constant or a scolum function, right? Here we have just removed the universal operator from the beginning of the formula and put a question mark over there.
Yes, sir.
That is another way of representing universal quantification, right?
Um,
So this
Okay,
not
sir,
seen.
but generally when we, I mean, during the lecture, like it was told that during the columnization process, assume that if there are no existential quantifier, then we can write it directly in the form of question mark of x kind of thing.
No, question mark of x basically means for all x, not of t next.
Okay.
Yeah, maybe you can revisit the lecture videos and see if maybe if I am missing out something, or if you missed out something in the first watch of the video, and then let me know.
Okay. No, as of I remember, sir, like it was told that so if there is an existential quantifier, that should be replaced with the function of this universal quantifiers with this
Yeah.
column constant, and so universal quantifiers they can be as it is, like as of I remember.
Yeah, so we are not doing scolumization here. That's a separate criteria. Here we are
Okay.
just representing the universal quantification in a different manner using this question mark.
Hmm.
Okay. So the correct options over here would be C and D, right?
okay.
Because of
Yes.
what we discussed just now, this all form in the clause form.
Okay.
Okay. So let's move on to question 4 then. So now this question asked us to uh, solve it, simplify this particular formula given over here and convert it to CNF. So we had to choose among these four options which is the correct CNF version of this formula. Okay. So if you have a pen and paper around, I'll ask you to try to work it out in a couple of minutes, and then we can discuss the stepwise solution. Okay, so let's start going over these steps one by one, and let's see if the complete solution or the partial solution that you might have matches with the given solution. Okay, so this is what is given to us, right? We have A and B implies C in parenthesis, and this whole thing or A and B and D. Okay, so the first simplification that we are going to do is we are going to rewrite the implication as not of B or C. Okay, so we have A and not of B or C, and this remains as it is. Okay, and then we are going to distribute in the next step we are going to distribute OR over the AND. Okay, so basically this OR, this one, is going to be distributed over the AND operator over here, right? So this becomes A OR, so this A here, this A here, or from here, this whole thing, A or A and B and A and B and D, and with this AND comes from here, not B or C, which comes from here, or which comes from here, A and B and D, right? So this is just De Morgan's law. So we got another simplified version of the formula. In the next step, again we'll distribute OR over the AND, okay, to trying to simplify this further. Okay, so on the left hand side in this part, we first have A or A, then AND A or B, and A or D. Okay, and then on the right hand side we have not B or C or A, and not B or C or B, and not B or C or D. Okay, this is another simplified version of the formula. And now we'll simplify the innermost level. So this A or A becomes just A, right? A or B remains as A or B, A or D remains as A or D. Over here, not B or C or A becomes one thing, not B or C or B, we just remove the parentheses from here, right? And then we have not B or C or D, right? Now we will remove the unwanted parentheses. Okay, so when we do that, we are left with this thing. We have A and A or B and A or D, and not B or C or A, and not B or C or B, and not B or C or D. Now the trick is, this particular part over here has both not B and B, which makes this a tautology, right? Because if you have not of something or something, that thing will always turn out to be true, right? So we replace this not B or C or B with a true. Okay, and anything and of true is just the same thing, right? So we can simply remove this particular part from the previous simplification, and this is what we get. We get A and A or B and A or D, and not B or C or A, and not B or C or D, and each of these form a clause. So first clause is A, this is C1, A or B is C2, A or D is C3, this is C4, and this is C5, right? And each of these are connected by AND operators. So this eventually forms the conjunctive normal form. Okay, and if we match this with the options that we have, we will see that the correct option is option B. Okay, I'll leave this step by step simplification on here for a minute so that you can go through it and convince yourself that it is in fact correct, and then we'll move on to the next question. Okay, so any doubts in this question till now?
No, sir.
Okay, great. Then if not, we can move on to the next question, which is question 5. Okay, so this question now asks us about columnization. So here we are told that each option, sorry, let me go to the other tab. Yeah, each option contains a first order logic formula and a columnized formula on the right hand side. We have to select the option that show the correct column formula. Okay, and here sk could either correspond to a column constant or a function. Okay, and yeah, so for example, in the first option, option A, we have there exists x for all y p of x comma y, and the given candidate's column form is p of sk1 comma question mark y. So you have to decide whether this is a correct columnization or not. Okay, and we have to do that for each of the options. So again, I'll let you try to think over it for a couple of minutes, and then we can look at the step-by-step solution. But yeah, feel free to share your thoughts in the chat box once you have some partial solution or the complete solution.
Option A, B is correct.
Okay, we have one vote for options A and B. What about the other ones?
Option B could be correct, sir. Just thinking of option A.
Okay, sure. We have another vote for option B. So one way you could approach these kind of problems is that you yourself try to do the columnization first of the left hand side and see whether your derived columnization matches this columnization given over here in the option on the right hand side for each option, right? For example, for option A, we have been given there exists x for all y, p of x comma y. So what do you think would be the correct columnization for this?
For there is a column constant sk1, and for all y, question mark y is correct, sir.
Yeah, so remember there are two types of columnizations, one where we replace something with column constant, one where we replace something with column function.
Column function, yes.
Do you remember what were those criterias?
Yes, sir. If existential quantifier is not under the
Scope
universal
of,
quantifier, then at
yes,
that time we will use the column constant.
that's right. So in
If
option A, yeah. So in option A, which of those things do you think is satisfied? The existential quantifier is occurring before the universal quantifier, right?
yes,
So that is not falling in the scope of the universal quantifier. So in that
yeah,
case, it should be
we will use
replaced with a
the
column constant,
yes,
right? So
and
we will,
if
yeah, go ahead.
for B, if the existential quantifier is under the scope of the universal quantifier, then for that we will use the column function.
That is right. And by that logic, option B is also correct.
Correct, yes.
What about option C? Follow the similar logic, identify the existential quantifiers, see whether they are in the scope of a universal quantifier, and then see whether they can be written in this column, whether they can be columnized. But before doing that, remember that what is given on the left hand side, you might have to simplify that, right?
Yes,
So
sir.
in option C, you
The
are given,
implication is given.
yeah,
So the
exactly.
C is the correct option.
Yes, C is correct, but let's see how that is correct. So let's
So
for
whenever we will eliminate the implication, at that time we will find the negation P or Q.
that's right. So yeah, so like we discussed, A and B are correct. Let's look at option C only. Okay. So first, what we are doing is we are rewriting this implication. Okay.
Yeah.
So then it becomes for all y negation of this whole thing or R of y. right? And when we push the negation to the deepest level over here, this not of existential quantifier x, this becomes a for all x, okay?
Yes.
And then we keep pushing the negation, so eventually we end up having two universal quantifiers and no existential quantifier at all. So if you go through this step by step solution, you will see that we end up with something like this, okay? And this in fact has no existential quantifier, so there is no need of scolomization at all in option C. So the scolomized version of this formula will be simply just this thing, the the universal quantifiers replaced with the question mark counterparts essentially. So option C is correct. Option D, because of the same logic, is incorrect because
It will not.
yeah, it shouldn't have any scolomization, and here there is a scolomization given in the right hand side, so this scolomization is incorrect. So the correct
Yes.
options are A, B and C. Again, I'll leave the stepwise solution here for a while. Please let me know if there's any confusion at any point, and then we can move on to the next question.
Yes, sir. Actually, in connection to the previous doubt when we are discussing about CNF form,
Yeah.
like I was asking.
Yes.
So assume that in a formula, if there is no existential quantifier at all, and if
Yeah.
you want to write in column form, I think so we can straightforward replace with question mark
That's fine.
x and question mark y, right?
That's perfect. Yeah.
Yes, yes, sir.
Okay. So if there are no doubts here, let's move on to the next question, which is question number 6. So here we are given two knowledge bases, KB1 and KB2. Okay, each of these have a set of facts or statements, and we have to decide whether each of these are consistent or inconsistent. Okay. So yeah, again I'll let you think over it, try to solve it and see if each of these end up being consistent or not, and yeah, and then we can discuss the solution after a couple of minutes.
Sir, can you please explain what is consistent and inconsistent?
Okay, so yeah, I will again recommend that you revisit the lecture videos for a detailed explanation. For now, I can say that you try to see whether with different rules of inference that you can apply on the different facts.
Actually, I have doubt in that consistent and inconsistent.
Yeah, so I'll just give a brief overview of what that is. Um, with the given facts in the knowledge base, right? You try to apply different rules of inference and derive different facts. Okay, and if you see that there is a contradiction happening at some point of time in some fact that you have derived to be true, then that is inconsistent. Okay, otherwise it is consistent. That is a very high level idea of what consistency and inconsistency is, but there are methods that you can apply to check that, some of which might have been covered in the lecture videos, and you can follow that as per your comfort level.
Sir, actually, like if you could, I mean, anyhow, we will be referring the lecture too, but like if you take a very small example and explain, I think that will be great help for us, sir. Very small example.
Okay, let's
Yes,
do
sir.
one thing. Let's take this example itself and try to solve it.
Yes, sir.
Okay, sir.
Okay, so let's take the first knowledge base first. Okay, KB1. Here the different facts given to us. So this gives us 4 facts. Okay, the first fact is D and F. Second is A or not D. Third is F implies not of A, and fourth is A and D together imply B. Okay, now we'll see what are the different facts we can deduce from the different facts given to us in the knowledge base. Okay, so from the first one over here we have D and F, right? So if D and F together is true, both D should be true and F should be true, right? So we can add D and F to the knowledge base. Okay, now we have added D and F to the knowledge base. Now let's use this D which we derived in 0.5 and this A or not D given to us, right? together to come up with using that we arrive at A, right? So because this tells us that A or not D is true, right? So basically what is given to us as of now is that A or not D is true. For this to be true, either A has to be true or not D has to be true. Do you agree with me?
Yes, sir.
But
Yes, sir.
from 5 we know that D is true. So not of D will be false. Do you agree with
False.
Yeah.
me?
Yes, sir.
Yes,
So
sir.
for A or not D to be true, A has to be true.
Yeah.
Do you agree with me?
Yes,
Yes,
sir.
sir.
That is essentially what is disjunctive syllogism. It's just a fancy way of writing that. So using this argument, we derived that A is also true, right? Now let's look at F that we derived in point 6 over here, and this fact number 3 over here, right? F implies not of A. Because we have F to be true in point 6, and using F implies not A, modus ponens gives us not of A to also be true. Do you agree with me?
Yeah, yeah.
Yes, sir.
But we see that we have said that both A and not A are true as per our
Yes, sir.
derivation.
Yes.
Therefore, this knowledge base becomes inconsistent. Okay.
Sir,
Now,
so it means that if we check, if we are given with any knowledge base
yeah,
with some formula, assume that at least if one formula is false, like one formula is giving us contradiction, then we can say that it is inconsistent, right?
yeah. Whenever you encounter one contradictions, you can stop there and say that it is inconsistent. You don't have to check for all possible derivations.
Okay. So, in other way, can I say that for suppose in our knowledge base there is a negation of A, and in another formula, say A or D, for example, then directly I can say that knowledge base is inconsistent, right? Because one
Can you
there is
come
an
again, sir?
negation A, and another formula there is an plain A. Can I
Can
infer like that, sir?
can you come again, Sham? I couldn't hear the statements that you said. So,
Okay.
so you're saying that
Assume
we have some knowledge base where we have not of A, and
not of A,
yes,
and there is another formula A or D, for example.
A or D. No, here we
So,
can't say that it is inconsistent directly, because see, here we have an OR operator connecting A or uh, A and D, right? So if this is true, either A is true or D is true.
okay, okay, okay.
Okay, but based on another fact in the knowledge base, we say that not of A is true, which means that A is false.
Hmm.
Because A is
Yes, sir.
false, the only thing that we can deduce here is that D is true. We cannot say that both not A and A exist in the knowledge
Okay.
base. So whenever,
Actually, I mean to say conjunctions are not disjunction. A
yes,
and D.
if there was a conjunction here, then yes, then it would be inconsistent.
Okay, no need of like even checking or deriving other facts also. Directly by seeing, I think we can say.
Yeah, even when you encounter one contradiction, it is inconsistent.
Okay, okay, sir. Thank you, sir. Got it.
Okay, so now that we have discussed knowledge base 1, let's go over knowledge base 2 as well. So here we have 5 facts given. Okay, based from the first fact, which is a conjunction, we say that C and D both are true, right? Then again from 6, which is C, and this point over here, using disjunctive syllogism, we say that A is also true.
Yes,
Okay, based on similar to the reasoning that we applied over here.
yes, sir.
Then from point 7, which is E, and formula fact 4 or formula 4 given over here, with this implication we use modus ponens and say that not of D is true.
Yeah, yeah.
Okay,
Yes, sir.
and then from point 9, where we have not of D to be true, and this fact 3 over here, F implies D, we say that
Yes.
not of F is true from modus tollens. Okay,
Yeah.
and at this point we realize that no further derivations are possible, so we stop and we see whether there are any contradictions in the knowledge base. And here we see that there are no contradictions in the knowledge base, because there are no set of these literals or formulas for which we have alpha as well as not alpha, right? For example, if not F is there, we know that there is no F in the knowledge base, which is true. Similarly, if we have an A, we know that there is no not of A, that is true. So we do not find any contradictions, and here and hence knowledge based 2 is consistent. Okay.
Okay, sir. Understood, sir.
Okay, great then. So the correct options would be knowledge base 1 is inconsistent, but 2 is true, consistent. So option D is correct. Okay, I hope that was clear. Let's move on.
Clear, sir.
Okay, great. Let's move on to question 7. So this asks us which of the following clauses correspond to equality axioms. So let's have a look first at what exactly do we mean by equality axioms. Let me try to find that. So here we have the equality axioms given to us. Okay, there are many of them. We'll just need a few of them, the first 3 of them, to answer this question. So I'll just go over those only, and then you can look into the other ones later on. So the first one says this is the reflexivity axiom, which says that for all x is equal to x. Okay, and then the second one is symmetry, which says that for all x and y, x equals to y implies y equals to x. And then the third one is transitivity, which says that for all x, y and z, x equals y and y equals z implies that x equals z. Right? So these are the 3 important equality axioms that we are going to need to answer this question. And let's go back to the questions and see which of these actually correspond to the equality axioms. Okay, so I'll let you think over it for a minute, and then we can discuss the solution. So notice here that here we have converted the universal quantifiers into this question mark form that was there in the that we usually encounter during scholemization. Okay, so
B is correct.
B, sir.
okay,
B is definitely.
we have 2 votes for B, which is correct. B is actually a correct option, because in option A we have a negation in front of this thing, which is not what the reflexivity axiom is. So B is the correct one, and this corresponds to the reflexivity equality axiom. What about the symmetry and transitivity ones? So one
C is
giveaway is
correct.
that either C or D would be true, and either of F or E or F would be true. We just have to select which of them is correct.
C is correct.
Okay, are you sure? Let's go over the symmetry one.
Symmetry.
So here we have an implication. When you simplify this implication, what will we get?
Negation here, or
That's right.
negation x equal to y, or y equal to x.
That's right. That's perfect. So because of that, option D is the correct representation of the symmetry equality
Yeah.
axiom. Okay, and now we are only left with the transitivity axiom. So which of options E and F do you think is the correct representation? I'll show the axiom once more. So here we have x equals y and y equals z together implies x equals z. So if you simplify this particular implication, what will you get?
Yeah.
Negation will be applied,
Negation,
and
Yes, negation will be
negation x
applied.
equal to y, or y equal to z, or x equal to z,
Yes, so we will have negation of x equals y,
or y
or
equal to z.
negation
Negation
of
y equal to z.
y
or
is
negation
equal
of
to
y
z.
equals z,
Y
or
equal to
x
z,
equals z.
or
X is
equal
equal
to
to
z.
z.
So that is corresponding to option F,
Yeah.
right? So there should have been a parenthesis over here which is not present, but yeah, just assume that it should be there before the last or over here. So option F is correct and representative of the transitive axiom. So the correct clauses that represent or correspond to the equality axioms are option B, option D, and option F. Okay.
Okay, sir.
Okay, great. Then let's move on to the next question then, which is question 8. So here we are given a knowledge base, let's say knowledge base 3. Okay, and it is in clause form. Okay, here sk corresponds to either a Skolem constant or a function depending on the context. Okay, so these are the different facts given to us in the knowledge base. The first fact is not of house of question mark x or taxable question mark x. Okay, similarly there are other facts given to us. Now, which of the following options are possible resolvents produced by resolution method? So remember, you might have come across this resolution refutation method in the lecture videos. You have to just, for this question, you just have to see that which of the following options are possible resolvents that are produced by the resolution method. Okay, so again, I'll let you think about it for a couple of minutes. You can try to work it out, and then we can have a look at the detailed solution. Okay, so while you are thinking over the question, let me just quickly fetch some water, and in next two after the next 2 minutes, let's discuss the solution. Okay.
Okay, sir.
Yes.
Okay, so let's discuss the solution. So here the solution shows only some specific resolvents that are required to answer the question based on the options given to us, but there might be more resolvents and you are highly encouraged to try to work it out yourself. Okay, and that is what is mentioned in this first line here. As an exercise, derive all possible resolvents for this knowledge base, and the ones relevant to this question are given over here. So let's go over them. Yeah, so we are given 5 facts in the knowledge base. Each of these can be said to be a clause. So for example, the first one is not of house question mark x or taxable question mark x. Okay, and similarly we have 5 other things. So the first resolution that we are going to do is so there are two parts to this. Okay, so R1, first it shows what do we add to the knowledge base, and the second shows what substitution that we might be doing to arrive at that. Okay, so for example, in C4 and C5, if we do a substitution where this z is replaced with jack, then we can arrive at this house sk of jack, right? Because then this would become not of landlord jack or house
Yes.
sk jack, which is basically an implication. So landlord jack implies house sk jack, and we have landlord jack, so together with that we arrive at house sk jack. Okay, so is R1 clear?
Yes, sir.
Okay,
Yes, sir.
okay, that's great. Similarly, we will arrive at R2. Here we will use the substitution of again z equals jack, but with respect to C3 and C5. Okay, so here in C3 we'll replace, so this should be y actually, not z. Okay, so we will replace y with jack. Okay, and C3 also, if you think about it, it corresponds to an implication. It is basically landlord of y implies owns y comma sky, right?
Yes, sir.
Okay, so here also we'll replace y with jack and we will arrive at owns jack comma sk jack using modus ponens. Okay, then in R3 we will substitute x with sk jack, but here the substitution will be between R1 and C1. So in C1 we have not of house x or taxable x, which again implies house x implies taxable x, right? Do you agree with me?
Yes, sir.
Okay, so C1 says that house x implies taxable x, and from R1 we derived house of sk jack, right? So we just replace x with sk jack, and then using again modus ponens we derive a taxable sk jack. Okay, similarly we follow certain other substitutions. We, for example, in R4 we substitute u with jack, v with sk jack between R2 and C2, and then we arrive at not taxable sk jack or taxpayer jack. Okay, so we are doing two substitutions here. Okay, is this clear?
Yes, sir.
Okay, that's great then. And then using R3 and R4 together, so here we have taxable sk jack to be true, and R4 says that not of taxable sk jack or taxpayer jack. So again, by this disjunctive syllogism we will say that taxpayer jack is also true, right? um, then based on the substitution of x and v, um, in C1 and C2 we can arrive at this particular R6 over here, which is not of house v or not of owns u comma v or taxpayer u and more. Okay, so these are the ones relevant to our question over here, but there will be more such substitutions and resolutions, and you should try that out, and eventually you will see that um, owns sk jack comma jack cannot be derived, and not of taxpayer jack also cannot be derived. Okay, and with this information in mind, let's go back to the question that we had. So here this basically asks us which of the following are possible resolvents produced by the resolution method. And let's see. So we were able to derive house of SK Jack, right? In R1 over here. Next we have taxpayer Jack. So were we able to derive taxpayer Jack? Yes, in R5 over here. Next we have owns SK Jack comma Jack. This we were not able to derive, right? So option C would be incorrect. And then option D, we saw that we were able to derive using substitution, which is over here in R6. Okay. So the correct option would be A, C and D can be possible resolvents, but B cannot be. So again, I'll leave this substitution thing on here for a while so that you can go through them and convince yourselves before we move on to the next question.
Sir, I think in this kind of questions, I guess reverse engineering works better, right?
Yeah, it can work better if you want to be thorough and you want to make sure that
Yeah.
yeah, not thorough, but if you want to be efficient is the right word. Yeah,
Yes.
reverse engineering could be a good hack.
Sir, but so you are asking about the resolvents, and the process is similar to this unification, right?
Yeah, so basically, because you are given things in the form of this squalemized version of basically you are given squalemized version of the formulas, right? And some
Yes.
of the facts in the knowledge base are just facts. For example, this unit facts like landlord Jack, which is given in C5,
Yes, sir.
right? So you have to do unification in order to do some simplifications or derivations. So
Okay.
unification is a part of that process.
So, like in a question, like in future, if we come across something uh, tell about possible resolvents, then it means that it is asking us to find the unified forms, right?
It is
What are the
asking you to
possible
find the possible
substitutions?
resolvents. To arrive at the possible resolvents, you might have to do some sorts of unifications or substitutions, depending on the kind
Oh,
of knowledge base given to you. If the knowledge base
oh.
doesn't have any scope of any unification, then you don't have to do that.
So, in the sense, like you mean to say, like so, if the knowledge base consists only like a predicate logic, there, I think this cannot be applicable, right? We can't
If
say
the
that
knowledge
it
base,
should be.
let's say the knowledge base doesn't contain any variables at all, then you don't have to do any further simplification and no unification and substitution should be required.
Yeah, yeah, yes, sir.
Yeah. Okay, then I hope this was clear. Let's move on to the next question then. So now the next question asks us use the resolution refutation method to determine the correct entailments. Again, so this concerns us with only two possible resolvents, and you have to just say whether these could be entailed by the knowledge base or not. One is taxpayer Jack, another is landlord Jack. So which of these do you think would be correct based on the derivation that we just saw?
Taxpayer Jack.
Taxpayer Jack. What about
Sir,
landlord Jack?
entailment means the possible derivations, right? In the simple words.
Entailment is derivation that are necessarily true.
Okay.
Okay. So let me go back to this thing that we did, and here you see in R5 we arrived at taxpayer Jack, right? Do you agree with me?
Yes, sir.
So taxpayer Jack is something that we know is true. Also landlord Jack is a part of the knowledge base itself, so we know that this is also true because anything given in the knowledge base is assumed to be true,
Yes.
right? So if you go back, so the correct entailments would be A and C.
C.
because we can entail both taxpayer jack, also landlord jack, given the knowledge
Yeah.
base. Okay. Okay, then let's move on to the 10th question. So this question asks us, in general, when we apply the resolution refutation method on a set of clauses in first order logic, what happens? Which of the following do you think could happen? Does it always produce a unique proof or derivation? Does it always terminate with an empty clause? Does it always terminate at all? Or none of the above are true? What do you think? So this is again
None of
kind.
them.
Okay, so we have one option for none of the above.
Yes, sir. I think none of them.
That's right. I think none of the above is the correct answer. This is kind of an example of a conceptual question where it's not exactly
Yes.
a recall question, but something that you learned in the course, and you just have to apply the concept that you learned over there. And yeah, so option A is incorrect because it's not always only a one unique way of deriving something. There can be multiple ways of deriving a fact, so it doesn't always produce a unique derivation. It's also not necessary that it always terminates with an empty clause. It might not always terminate, and option B and C are actually kind of interrelated. It might not always terminate, and hence both options B and C are also not true. So the correct answer would be none of the above.
But actually, in the lecture, when we are discussing about a resolution reflection method, so most of the examples told was like it is able to derive the empty clause,
Yeah.
except in that prologue lecture when the professor was telling about that binary trees.
Yes,
So that time he was telling about that recursion kind of thing,
that's right.
repeated kind of thing. But so once again, this is an ambiguity, sir, because whatever the examples were given till like week 5, like we were able to get an empty clause.
Yeah, so it's not exactly an ambiguity because so I think the examples that were given were like simpler examples that involve terminating with an empty clause, so that the concept is conveyed in a correct manner to the students. But yeah, there is this nuance that there could be possible cases where we are not able to terminate with an empty clause.
Yes, sir. Because at least if one case, if we were discussed about not deriving at an empty clause, that's fine. But if just think as an just a Navy student who is not accustomed this subject, then definitely we get confused. Okay,
Yeah.
so
I understand
then
that.
it's kind of
But this question is essentially just to like keep yourself aware of the fact that there could be these outlier cases where it doesn't always terminate.
yes, sir, yes, definitely.
Okay, then. So this actually brings me to an end of the questions I have for today. And is there anything specific that you would like to discuss? If not, we can close the session and then meet again tomorrow to discuss week 6 questions.
Sir, I have a doubt from assignment 4, week 4 assignment.
Okay, which question is that?
Sir, question number 10.
The graded assignment?
This weekly assignment that is given to us.
This one,
Question
right?
number 10. Sir. Yes, sir.
Question number 10.
Yeah. Sir, how the answer will be none of the above, sir?
According to FOL semantics, which of the following are true in the LPFC defined above? So we have to look at the LPFC defined above first. Where is the LPFC? Okay, so this is what is given. Consider a domain, a universe of discourse of people and pets, and a first order logic language, where P equals to pet 1, dog 1, cat 1, so on and so forth. Okay. Okay. Okay, so the constants here are Bush, Joe, Commander, Spot, and Fido. And then we have predicates or relations which are pet, dog, cat, owns, and likes. And then you have functions which is breed and size. Okay, fine then. So what does question 10 ask us? Dogs are not cats, dogs are cats are pets, none of the above. So is this question somehow related to any of the previous questions where you arrived? Dogs are not cats.
Yes, sir. Question number 6, some question was given like that.
Okay, so here we are asked to express in
I
first
was,
order
uh, I was
logic.
about to ask the question number 6 actually. I think.
Uh-huh.
Uh, last-
Okay, so one way I can think of this is that um, we cannot necessarily say one of these is true because okay, firstly we don't know anything about the first order logic other than the LPFC construction itself. So we know the predicates, we know the functions, and we know the constants, but we don't know anything that is there in the knowledge base. So we can form different FOL representations of different statements. For example, what we are doing is questions in questions 5 and 6 over here. So these are different. These sentence expressed in first order logic form is one of these, right? This is the correct expression, but we don't know whether each of these is true or not, and that can be decided only by a knowledge base given to us. And I think that is why it says that none of the above. But then I would request you to post this query in the discussion forum and verify it from there as well. Does that make sense?
Okay, sir.
Okay, so when you post it in the discussion forum, also mention the line of reasoning that you came up with, or the one that we discussed right now, so that when the main TA Bhaskaran sir answers that, he won't have to start from scratch. He can just point out if we are correct, or if we are not correct, where exactly we are going wrong. Okay.
Okay, sir.
Okay, then anything else? Okay, if not.
Sir, sorry, sir. I have a doubt. Question. Last week's graded assignment, sir.
Okay.
Last week's graded assignment. Question number 7.
Is that is week 4, right, or is it week 5?
Week 5, sir.
Okay. Which question?
Use the resolution method to derive all the resolvents for KB1.
That's right. Right, so we have to derive all the possible all the possible resolvents, or basically all the things that can be derived from this knowledge base.
Yes, sir. Actually, sir, I was confused. The right answer gives bottom, false of bottom. Can you
Yeah.
please explain? The right answer is
The resultant also A false or R or A. Also
R or A.
the
Yeah.
resultant is. So
Okay.
whenever you will.
Um. Okay, I need to think over this. Um. Okay, can I try to solve it today, and can we discuss it tomorrow?
Yes, sir. Yes, sir.
Yeah. In the meantime, also feel free to post in the discussion forum so that we can, if we can get an answer there as well, then we can discuss it there, or we can discuss it tomorrow first thing. Just remind
Yes,
me
sir.
if I forget. Okay.
Yes, sir. Thank you so much.
sir, actually, my call got disconnected. I was about to ask question number 6, sir, from assignment 4.
Okay.
Sir, actually, I remember in our earlier sessions, conversion of English sentences to this a logic kind of thing. That time, like you were telling that we need not worry about the semantics of the sentence. Rather, we just want to focus on the how we can place the connectivities. If I'm not wrong.
Yeah. English semantics. We don't need to concern
Yes.
ourselves with the English meaning of that sentence given to us.
Okay, okay. Sir, if that is the case, it is given that express in FOL logic. Dogs are not cat.
Yes.
So it is clear, option third option is clearly saying that.
Uh-huh.
But so when evaluation process happens, it is also telling that the fourth option is also correct.
That's right.
So so then I feel a bit confused, sir. Like whatever is given in the English statement, that as it is we have to take, right? Then how can be the option number four could be correct, sir?
So replace dogs and cats with something else. Okay. Think of dogs as X or cats as Y. X are not Y. That is what you have to express in FOL. Okay. So that can be expressed in either in one way, that is in the terms of what option 3 says over here. Okay, maybe we should use another variable name. Let's say D are not C. Okay.
Yes, sir. That is clear, sir.
So for all X, D implies not C. Okay.
Yes, sir.
But that also implies that if something is C, this implies that it is not a dog, right? Because
So
if
then if
something
that is the case, there should be existential quantifier, no, sir. Like some cats are not dogs, kind of thing.
no, so that is not our case. Not It's not like some cats are not dogs. So basically, whenever something is a dog, that is not a cat. That is what is given to us, right? So if something is a cat, this implies that that is not a dog. Don't think about it in terms of cats and dogs. Just think of it in terms of this variable C and D.
Okay. So you are telling that
So basically, what I'm saying
P
is,
is
let me
sure.
complete. Let's say we have
Okay.
a we have something called C. Okay.
Yes, sir.
And we know that if that C had been a D, right, it wouldn't
Yes,
have
sir.
been a cat. It wouldn't have been a C. Are you following me?
Yes, sir. Yes, sir.
So whenever it is a C, we can say that it is not a D. So that is why the fourth option over here.
Uh,
Okay.
okay, sir. Sir, actually, and one more thing is sir, when we come to question number 8,
Okay.
so actually, I exactly didn't get how to get to that options. Like how come like option number one, this thing is true.
So you have to select the model for the sentence. Okay, model is something that we you might have come across in the lecture videos. Basically,
Yes,
some assignment of these values to the different variables given in the sentence, so that the sentence becomes true.
yes, sir. True.
Okay, so you just try to replace these different variables with the different constants given over here and see if that makes sense. For example, the first one says that X will be replaced by bush, Y will be replaced by spot, and so on and so forth. And you see that if
Yes,
that forms model of the sentence, as in whether that ends up being true for the sentence, and then accordingly you can decide whether it is a model or not. Or a better
sir.
way to do that, instead of just doing that, is to add the negation of that goal that you want to achieve, and then you solve it further in using the procedure that we discussed in the previous week's live sessions or the lecture videos.
Sir, actually, if you don't mind, can you explain for option number one, sir? So rest of the option I'll try to do it, sir.
I would encourage you try to do it for option one. You post it on the discussion forum, and then let's see how does Bhaskar sir respond. And if that is not clear, then we can go ahead with that discussion. Does that sound good?
Okay.
Okay.
Okay, sir. Yeah.
Because that would also help the TA understand where exactly the issue is happening when you write down your thought of like the thought process or your line of reasoning. Then the TA will be able to like kind of get an idea of where exactly the confusion is happening, rather than the TA just giving the step by step
Okay. No, I understand, sir. You
yeah,
are trying to focus on so you want to clearly know where the point is, but the thing is sometimes like uh, the fundas we are understanding, sir, but when we put the pen on the paper, it's not moving. So that's what so previously you have explained what is an inconsistent database like KB is
yeah, yeah.
knowledge basis. Now the concept is clear. If such kind of questions were posted, then okay, a bit confident that we can do. But so when we start solving, sir, different things are coming into the mind. Okay, why not this? Why not that? What is this? And finally, like we are not able to write anything.
So I would
The
say
problem.
you start with, so when, because now you are learning, now you're not like writing an exam or something. So I would
Yeah, yeah.
suggest you write down everything that is coming to your mind. And if they seem like they are not related to each other, if they are contradicting each other, you write down in separate boxes or separate papers, and then you post all of that on the discussion forum, and then you ask the TA which of these is correct, where exactly am I going wrong. If something is not correct, why is that not correct? Then I think that will help you kind of understand or get an intuition of how to proceed with these things. Does that
And
sound
sir,
good?
like one more thing, sir, can we get the solutions for the assignment, sir, once the assignment date has passed? Because like for other subjects, we are getting solutions, and like shortly they're mentioning why that option is correct.
I know, I know. So earlier, this course also used to do that. I think that that process has been stopped in the last 1 or 2 semesters, and I think that is also that is firstly handled by Bhaskaran sir, not me. So because he
Okay.
prepares the assignment, so he has the solutions. Um, I think a couple of students have also raised this doubt on the discussion forum, and the consistent response of the team has been that you post your, if you're facing any problem, you post your potential solution, and then he can point out where exactly the issue is, that, which is what I was also reiterating over here. So that is what we have been following. But yeah, I can forward this request to the team, but I'm not sure whether it will be any fruitful, because in the last 1 or 2 semesters, this is what has been continuing with respect to
Okay.
the assignment solutions.
Okay. And actually, sir, anyhow, as you said, I'm also going through that form. Like I have read even that response, but anyhow, like what you told, like once again, like I will post it on the group, like when I find some free time.
Sure,
Sir,
sure.
actually, like, the one request is like, why we are asking is like, you know that this is a distance course,
Mm-hmm.
firstly like online course and distance course, and most of us we are employed in private colleges, definitely in teaching field. So we are overheaded with the work, and you know that when once if we like even some are doing like it is I have understood from the post that some are doing, but like most of us, like sir, so when we start doing these solutions, we need to spend lot of time, right? So which is like slightly distracting our regular activity. No, we are not asking something that I mean something extra, like we are not posting some new questions and asking, like many of the nptel courses once the assignment due date has passed, they are officially releasing a key. It is a kind of like gate exam, how officially they are giving the key, it is a kind of that, sir. So if that is given, what I feel is like, so when we read that justification, some of the doubts may be clear. But if still some doubts exist, then we can post in the group, so that
Yeah,
even your
yeah.
burden can be reduced, and also like we could be comfortable of writing that.
I understand that, Mr. Sham, and unfortunately, that from on my side, I don't think there's anything that I can do, because, like I
Okay.
said, that this is handled by the other team, the main TA,
Okay.
Mr. Bhaskaran sir. So yeah, if there is a huge outpour where you request him to post solutions, then that would be great. But yeah, I can request him from my side. I think I've done that previously also, but I think the team has been consistent on the trend that we are continuing right now, wherein the students post their partial solutions, and then the TA help them out with the complete solution. So yeah, I can again approach the team from my
Yes,
side
sir.
and say
Because
that this is what has
why
been
I'm telling
requested.
like
Let me complete,
yes, sir.
please.
Why I'm telling
So let me
like this is
complete, please.
yes,
um,
sir. Yes, sir.
so yeah, like I was saying, that that's all I can do from my side. I can request the main team to start posting solutions, but I cannot guarantee whether that will be done or not, because that is frankly not in my hands. So
Yeah, yes.
I'm kind of
But
restricted in those terms.
yes, sir. But one thing, sir, actually, we really like your that we really like the way you explain, and so like to be frank, like I'm like I don't know about others. I myself was waiting for the week for this live, I mean live session, sir. Like once you start this I mean once you finish this live session, then I'll start solving my assignment actually. So but unfortunately last week it missed, even I scored very less marks. And
That's
so like
that's
I really would like to thank you, sir, because if you're not there, then really this subject would be very tough. And so I'm going through
that's
the discussion form even. So
yeah.
Bhaskaran sir he's responding only if we show some rough work. So
Yes.
I think he might be thinking that we are just not at all working and we are just simply posting, but there are many constraints are like which we can't explain, because you can understand, right? If somebody is coming to seventh week of the course, he's at least a bit serious in this, because this kind of very new ambiguity course, if somebody wants to drop or time pass, initially they'll be dropping, sir. But if somebody is at this point, then at least one should understand that there is something like I don't say 100% seriousness, some seriousness in this course. But the same things are like once we come back from the work of 8 hours or 9 hours hectic work, there would not be such peaceful mind to solve these solutions even in rough work. Then he's just simply telling that so it is very easy, like if you hear the lectures you can you can understand it, some questions directly when you see, like you can answer it, this kind of thing. So I just I mean I'm telling you, but I don't want to post in the group, but because this may create some kind of contradictions there. But the thing is, sir, like one thing I want to tell, like I don't know how many of they are facing this thing. So the some subject like this, which is having some ambiguity, there should be some good help, sir, rather than always asking for the rough kind of thing. And you
I
know
get
that,
your
so
point.
if the questions
Can
are
I?
very easy and you can solve it by seeing, then why the pass percentage very less for this course, sir? Only 10% is pass percentage, right?
I get what you're saying, Mr.
Yes, sir.
Sham.
Like I
But
think,
I'll just
no,
can I just complete this?
Bhaskaran sir is just thinking from the topper point of view, not like average and a bit dullers.
Um, See, I don't know how to comment on that, but
Yes, sir. No, no, sir. I'm not asking your
can I
comment.
complete first? I think because the discussion is getting repetitive, so I think I should just conclude it with
Yes, sir.
yeah. I'll just reiterate what I just said, that unfortunately there's very limited things that I can do, and one of those is
Yes, sir.
conveying to the team about this request that has been coming up in the live sessions. And yeah, I will do that for sure. And for thank you for your kind words that you said initially, but also I would like to re-emphasize that whatever students achieve in the course is because of their own hard work. Teachers or us are just there to kind of aid them, but whatever they get is their own achievement. So yeah, kudos to all students who are putting in the effort. Yeah, so yeah, I'll just yeah, that's the only thing that I can do, unfortunately, is conveying to the team
Yes,
about the
sir.
request of the students. And yeah, I think it's not beneficial to
Yes, sir.
continue
Yes, sir.
this discussion
No
any
further
longer.
discussion is needed. I'm not asking you to tell the solution for this. Just I want to convey my opinion. And actually, from your point of view, myself, I'm 100% satisfied, sir. Like you tell the concept in a very simple manner. Like when we asked you about entailment, like definitely I know if the same question is posted in the group, then he will be asking for rough work, but you told it very simplified manner that could be helping for the assignment, sir. This much is enough for us, sir, because actually we are most of us are doing this one for AI, artificial intelligence domain course, rather for a research.
I
So if you are
understand, Mr.
for a
Shyam.
research, then definitely like what Bhaskaran sir suggests is very good thing. But I think
I
course.
understand. I'm again sorry for interrupting you, but because the session is being recorded and it will go on YouTube, um, I don't see the point of going through the same discussion
Okay,
again
sir.
and
Okay,
again.
okay, sir.
So
Definitely,
yeah,
sir.
I do get your point and I do relate to it as a student as well.
Okay.
But yeah, yeah, I would really, if you really feel that, if most of you feel that it will help, I highly encourage you to all of you to express yourselves on the discussion forum, so that the team can understand that it's not just one or two people who are facing these issues, it's a lot of them, and then they can recorrect their trajectories and maybe look at
Yes, sir.
alternatives possible ways to address this.
Definitely, sir. Like, so I personally expect the support, like you are giving in every live session, the same support up to the end of the course, sir. So now I'm a bit confident that like somehow I can pass the course, because initially like there is nothing in the mind like how I'm going to uh, get into this course. But now, like when you are explaining, when you are solving the old assignments and when you are solving this, now I'm okay, sir. Like a bit confident that okay, somehow I can try at least.
It's
Okay,
great
sir.
to
Anyways,
hear.
thank you, sir. Like as you said, it is getting extended, but okay, sir.
Yeah,
Thanks for your response, sir.
yeah.
Like whatever we are asking, you are telling you. Thanks again, sir.
Thanks for all of you. Thanks for your feedback as well. Thanks for attending the live session, and let's reconvene tomorrow at 6.
Okay, sir.
Okay.